Okay.
What does it say? Definite what? Integrals.
Definite integral. Maybe write it better.
No, it's integral.
Not integrals.
No, it is integral. INTEGRAL. At least that's what it says on the homework. Did you write something different?
Okay. So in this section, all they're going to do is have you basically find the area underneath the curve or underneath a function. They'll use a symbol, which we'll talk about in a second. It's called the integrand. So you have questions like this. We have the symbol, meaning integrate some function with respect to x. So the dx is telling you what variable we're focused on, because you can integrate with different variables, but we're not going to do that. That's more like Cal 3 stuff, but integrate a function within some bounds. So it'll be some from A to B. Okay, so the first question basically gives you a graph and a shape, and that's represented by a function, and you need to find where am I drawing my my region. So I'll give you a picture how it starts. So 1, 2, 3, 4, 5, all the way through 6. 1, 2, 3, 4, 5, 6. So there's 6. So you have a point right here. You have a point there. You have just a line. And the question asks you to find the area that's bounded on under the line. So the area in here. So the question will start out by asking you, since this is dx, we need to figure out, okay, where is the not domain, but the interval for your x. So I'm only going to find the area between 0 to 2. You see what I'm saying? Because it's closed off. So the integral will be from starting point 0 all the way until 2. And then they have to tell you what the function is. The function is going to be 6 minus 3x. So this is from the homework example 1. So your homework problem would be 6 minus 3x dx. So they would ask you what goes in here. Well, that's your function. Then they're going to ask you, okay, well, how far are we going? You say from 0 to 2. That's all you got to do. And the reason they know this, and we're not going to do the rectangle stuff, but in the book, what they do is put infinite number of rectangles underneath, like this. If you saw the video, you should know what I'm talking about. So you have a bunch of little rectangles. You got to figure out how far are the rectangles going. So they're going from 0 to 2. So if you minimize the width of the rectangles to infinitely small using limits, you get this smooth shape. It doesn't have to be a geometric shape. It can be any shape. Let me show you the question. You guys see this question?
Yes.
All right, so the f of x is a part that goes inside the integrand. So that'd be right here. You go from 0 to 2. The 2 is the bound. So they just wrote it kind of weird. So the blank spot is the 2 that we wrote. This spot right here is the function, which is 6 minus 3x. That's all you gotta do, just fill out the blanks. Okay, so what this means, you don't know what it means, that's all. So here's a function. I'm going from where to where on the x. It's always the x-axis. If you look at the y, then this has to be dy, which probably might not come up in this class, but just in case. If you have dy, that means your rectangles are going this way. But that's probably more of a Cal 2 kind of thing. You guys have any idea as to how we set this up? So when you solve this, you'll get the area, which we'll do a little bit later.
Somebody has the TV on.
What's that?
Someone has the TV on or the radio.
We input the number 2.
Oh,
Okay.
Yeah, sorry about that. I forgot to mute my mic. I'm sitting with my grandma watching the news.
Sorry. I had you guys on low. I couldn't hear it. Usually I mute people if they forget or if I hear weird sounds. All right. So yeah, any question on this? The basic idea makes sense? Like where everything goes? No, we haven't just started solving for anything yet. It's just basically what does this number mean? What does that number mean? What does this mean? All right, so this is the function. This is the starting point and the ending point. That's it. This is the variable I'm focused on. So that's why I'm going this way, x, because it's x, right?
Just a quick question.
Yeah.
So I was wondering, is the test 4 going to be due Tuesday night?
Tuesday, is that tomorrow? You mean tomorrow?
Yeah.
No, I can give you guys more time because we haven't finished talking about it, and last week didn't work out the way I wanted. But I'll give you more time. But I would suggest trying to get out of the way as soon as possible because finals are coming.
Yeah.
So, but yeah, I don't mind putting it on Thursday or whatever.
okay.
Okay. Yeah, thank you.
So let me show you the homework questions. So check this guy out, right? So it's dx, meaning I'm looking at it from here to here. So the lowest point is -4, highest point 4, right? What is a function that creates this weird little triangle? Well, that's this right here. So that goes in the box. That's all you do in the first 3, 4 questions. Actually, might be most of them. Oh, check this one. That's some changes. This is dy. Cool. So it does come up. Any question on this first few problems here? Does it make sense what I'm talking about?
Yeah, it
Okay.
makes sense, I think, kind of.
Will we have a graphing utility to?
Yeah.
Yeah.
Yeah, if I learn how to set that up. I messed it up last time for one of my classes.
Okay.
I didn't click the link.
Are you gonna put some of these easy problems in the final or the difficult ones?
Maybe. I haven't looked at the final. I'll check. I hope there's easy ones on there.
Yeah, last test, a lot of numbers changed in the setup. So I was like,
I mean, it can be exactly the same, right? All right, let's look at number 5 here. Notice how they changed it to dy. So let's write this one on paper so you can see the difference. This is a dx problem. Number 2. You have a function g of y equal to y cubed. And you have a graph. Let's see here. That does this. So they close it off right here, and they say find the area in there. Okay. So this is 2. This is 2, 4, 6, whatever. So since we have y, it's not x. We have to do an integral with a g of y dy from some a to b. That's an ugly g.
There are 4 or a y inside the parentheses.
That is a y. All right. So since I have a dy, I need to look at the lowest point on the y and the highest point on the y. So it's going to be going from 0 to 2. And then you put your g of y function right here. And it's dy. So the function, your integrand, and your integral limits. So they're pretty much all going to be like this for this homework. So can you look at a graph, determine the bounds, and put the stuff in the right places? I'm hoping this is an easy homework.
I do have a question about number 4 because that one winds up with cosine
Sure.
and it's dealing with pi and everything. So I'm a little confused in that.
All right, let's do it. So let's look at it. So f is your function, right? So that's number 3. They give me a function. It's going to be the exact same thing. Give you a graph. Let me write the graph here. 1. Okay. So they want to know this area. So the integral is a function of x, meaning I'm going to use dx. So I'm going to look at the lowest point of this region at 0 till pi over 2. So I'm going to integrate from 0 until pi over 2. And the function that made this is cosine. That's all you got to do.
Okay. Okay, I see where I got tripped up now. Okay, that makes a little bit more sense. I was doing a function of dy instead of dx.
Gotcha.
Oh well. Well, at least that finishes up 5.3.
Yeah, let's move on to 5.4. This one is more involved.
Well, I meant for me, that's all that's everything. I have all
Oh.
15 problems.
Gotcha.
That was the only one that tripped me up.
I have a question.
What's
Can you do one of the examples where it says use the geometric formula to evaluate the integral?
for the same section?
Yeah.
Let me see. What number was it?
8 and 9 have those examples.
8, 9. Oh, I see. Well, when they say geometric formula, they mean just like find the area of the shape.
Okay. Okay.
Yeah, they make it they make it sound more complicated than it has to be. Like, for example, when you graph this region, well, it's going to be a square or a rectangle. So you just do base times height, right? So that'd be 3 times 7, which is 21.
Oh, okay. That makes sense.
If you had a triangle, you'd use a triangle formula. But yeah, they made it sound difficult, right?
Yeah, a little bit.
Are we going to be touching on the review tonight?
What's that?
Are we going to be touching on the test 4 review tonight?
I think so. I hope so.
Okay.
That is the goal. All right, let's move on 5.4. Do you guys have any questions on 5.3? Any other questions?
Not for me, at least not about 5.3.
All right, one moment.
Maybe in a minute, after we're done with 5.4, I believe. Can you help me on one of the problems on 5.1?
What's up? Sorry, I didn't catch that.
Can you help me one of the problems on 5.1?
Yeah, well,
Later.
yeah, save it for when we're done. We'll do a bunch of them. Let me find accounting.
Sweet, I have a few problems that I need help with too. 5.1 and 5.2.
Okay, it's not the one. I think it's this one. Nope. Oh, here we go. All right, 5.4. Let's write down the theory because it's important. The fundamental theorem of calculus. All right. So if a function f is continuous, on the closed interval a to b, and f is an antiderivative, capital F. Antiderivative of lowercase f on AB. Then the following is true. The integral from A to B of your f of x function d with respect to x would be equal to capital F of B minus capital F of A. Okay,
What does it say after anti?
Derivative. So capital F is an antiderivative. So basically it undoes derivatives. It's the opposite.
Is that and after the interval AB?
Yeah, and F, capital F.
Okay.
No, I think we're mainly going to focus on the power rule. I don't think we're going to, let me check before I promise that. Let me see. Pretty sure. Mainly the power rule, but also the trigs. Trig will show up. So here's the power rule for antiderivatives. So if you're integrating a power function, meaning it's some x to the n dx, the answer will be x to the n plus 1 over n plus 1 plus c. Okay, so this is just for a general antiderivative. So the integral is also called an antiderivative, but I'll mainly be using the word integral. And that's what it means. So it'll start off with, well, let's do an example so you can see what I'm talking about. So let's say we have 2x dx. So you can pull out constants. It's one of the rules for integrals. So you can pull it out, not worry about it. Focus on the x dx. So this will be, the power rule says, add 1 to the power, and then divide by that result. And then add some constant. You add the constant if there's no bounds on your integrand. If you have bounds like this one, then you don't have to worry about the c. The c is only for indefinite. So finish this off, this would be 2 times x squared over 2 plus c. So the answer would be x squared, right? Plus c. So that is just your basic indefinite integral using the power rule. So this was a cube, a square, you would add 1, and it would become a cube. And you would divide by 3. So now let's do it with actual bounds. But before we do that, is there any questions here?
That is a capital C,
Yeah.
right?
What was the question? Sorry.
That's a capital C?
Yeah. C is just some constant. So the C basically is, in real life, is determined by initial condition of an actual problem. So like if this was a physics problem, then C would be determined by initial time, initial temperature, initial pressure, whatever. Right. But since
So that
it's
will,
generic, yes, what's up?
so that will be 0, right? Or the C? If
C,
it's neutral?
C is some number, we don't know, is determined by what's happening in real life. And since this is a general question, it's just some general constant C.
So can you repeat what you just said about pressure and this is used by what?
Yeah, like if we're working on a physics problem, the C will be determined by what's happening in real life. So if you had like an initial time, like you had an initial velocity or initial like a starting point, or if you had an initial temperature, that'll give you different C's. So right now it's generic with infinite solutions, but in real life we'll always have something that will tell you what C is. Okay, now why it's there, think about this. If you take a derivative of this, what do you get?
2x.
2x, right? Which is the original, right?
Oh, okay.
You see
Correct.
how they're opposites?
Mhm.
If you take a derivative of a constant, what happens?
0.
There's 0, right? So because this could be any constant, it's still going to be 0 because it's not there, but it could be there. I don't know. That's why we just call it some number. Okay. But this only comes up if it's indefinite, meaning there's no bounds. So let's put some bounds on there so you can see this won't be there.
So this is gonna be shown in physics one.
It
or
comes
what?
up in engineering, physics, basically any kind of like hard science. Derivatives and integrals will come up.
Got it. Got it.
Okay, let's do the same question with numbers or with bounds. All right, so same question. I'm going from 0 to 4 because remember these functions represent some sort of area, right? This, now that I have bounds on it, it's going to give me an area, not just the antiderivative. So the rule says add 1 to the power and divide by that result. But I'm not going to add the c because I have bounds to deal with. So I'm going to write the bounds to the side because I'm going to use them in a second. So you're going to get 2x squared over 2 from 0 to 4, which then gets me x squared from 0 to 4. So the fundamental theorem of calculus says when you find the antiderivative, you plug in the top one and the bottom one, but you subtract them. So what we're going to do is do 4 squared minus 0 squared. So this right here is the area. So it's always going to be the top number into the result of your antiderivative minus whatever's down here. It's always going to be like that. That's what we set up top. That's what this is saying. You find the antiderivative, which is capital F. You plug in the top number minus the bottom number. And that result is usually area. So going back to the last section, remember how we had those little areas underneath and we would, you can use geometry to figure it out, but now you can use the fundamental theorem to find area for any type of shape.
I have a question.
Yeah.
Since like it's not giving us a unit square, like a unit in meters or anything like that, do we have to put unit squared on the test, like to show our work, or can we just put like 16?
No, you don't have to put unit squared unless they specifically say it's in feet.
Yeah, okay, got you. Because on the videos, she was putting like unit squared on everything. But
I mean, technically it is because it's an area is some unit squared. But I'll know what you mean if you forget.
yeah, exactly. But I was just making sure that like it wouldn't be considered like an error on our part.
It's not an error, it's just bad notation.
Gotcha.
Like I would get into a habit of just writing it because when you get to engineering courses or physics, they're gonna give you crap.
Yeah, and then also on the test, do we have to write out the power rule? Like we have to do the like 1 + 1, or can we just kind of just write it out? It's basic. It's always basic math.
Yeah, if you show me this, that's good enough for me.
Okay, yeah.
You know, this
That's how I've been doing my work.
As long as it's coherent, I guess. Is that what you're saying, Jack?
Yeah, I mean,
As long as you can follow it.
I'm showing this because it's the first time we're doing it, so I shouldn't be skipping from here to here. That would not be cool.
Yeah.
Of course, when you're doing it, I mean, if you want to skip, just show me this part and then plug in these numbers. No, that's good enough.
Okay, yeah, I always skip the first part that you did, but I was just making sure that we didn't have to write out the rule.
No, that's fine. We're good.
I'm kind of the same way. I kind of jump around a bit when doing power and quotient rules and stuff because I have to think of it. And when I work on it, it's like I have to come back and correct myself, or else I'm using up half my book worth of pages just for one problem. Going step by step. Alma could vouch for that. She's seen my note process before. So
I gotcha.
I just try and make something coherent. And I'll skip a lot of the individual steps like the 1+1 or the move or the reorder or whatever.
Any other questions? You guys get the basic idea on how the power rule works and how what the fundamental theorem is telling you to do.
Yeah.
No, that's pretty clear, sir.
Let's do it.
Yeah.
So, yeah, here. Let me see. So number 2, let me show you.
That's almost as bad as mine.
See here they have 2 different parts. They also have a power. So we're going to have to expand this by using the exponent. And then you're going to integrate each term separately. So you're going to have an integral on each single piece. You're going to have 3 pieces. So there's a rule that allows you to integrate each part. So before we do number 2, let me show you what the rule says. So basically, if you have an integral, let's say x squared plus x plus 2 dx, the rule allows you to integrate each one separately. That makes sense? So integral of x squared, that would be x cubed over 3 plus x squared over 2 for this one, right? Plus, what's the integral of 2? What is the antiderivative?
It's 2x.
Yeah, so we got to think backwards here. If I take derivative of 2x, I would get 2. So going back, since there's no bounds, I have to attach my c.
How did you get that 3x cubed?
So let's show the step. So remember, it's 2 plus 1, 2 plus 1, 1 plus 1,
I forgot.
1 plus 1.
Thank you. I
Jack,
forgot.
your mic's about to feedback again.
Does that make sense?
Mm-hmm.
Yes, sir. Yes, sir. I forgot about that rule.
So that gives us x cubed over 3 plus x squared over 2 plus 2x plus c. So going to number 2 on the homework. Before we do, any questions on how we got to the end here?
Really, it looks self-evident, but anybody else have any?
No, that's clear.
I know I'm asking questions about the test, but like that first step, do we have to write it out where it's all separated like that? To show our work?
No.
Okay, so if I just skip that step and went to the next one, it would be fine.
Yeah, that'd be fine.
Okay, yeah, I don't know, the way that I've been doing it is just I've skipped that step. I don't know if it was very important to show it or not.
No, it's just important for me to show.
Okay, I got you.
Because this is a rule for integrals that you have a sum and difference that you can apply it to. Okay. So evaluate the integral. So this is number 2. So they give you an integral from 0 to 2. So they want to know the area. They use t, but I'm going to use x because my t's look worse and it's confusing.
Well, we can mix up your t's with y's, so it's
They look like pluses and y's and t's, and yeah, it's bad.
I'm the same way.
Let's stick with x. Okay, so
Variable is a variable.
I can't integrate this until I expand it, unless you use a special rule, which we're not going to talk about yet. So this would be the integral. So multiply this out. That would be what, 16x squared minus 8x plus 1, right? You guys double check me. Is that the same as this?
Yeah.
So at that point, just integrate each single one because there's no more power.
Yeah, that's correct.
Yeah, I'm with him.
So 0 to 2 dx minus the integral 8x dx plus a 1, which is just dx. 0 to 2, 0 to 2. So the integral will be 16x 2 plus 1 over 2 plus 1 minus 8x 1 plus 1 over 1 plus 1 plus x, everything from 0 to 2. So there's no c because we have bounds, right? So that would be 16x cubed over 3 minus 8x squared over 2 plus x, 0 to 2. So the rule says you plug in the 2 first. Then you do minus, plug in the 0. I'm out of space. You cool if I put it down here? Does that make sense?
Can you
See how
scoot
it's
the
all going
paper
to
a
be
little
0,
bit?
right? Is that clear or no? Is that legible?
Can you scoot the paper a little bit?
Yeah, this thing was in my way. Here we go.
Yeah. Did you want to put the cubes and the squared on the one for the value of 2, x value of 2?
Yes, we should. But let me rewrite it in the next page. Well, I'll wait a bit. All right, so let me put this on the other side over here. So we had 16 times 2 cubed minus 8 times 2 squared, right? Plus 2. Is that right?
Yes.
Okay, 16 times 0 minus 8 times 0 plus 0. So this whole thing is 0. So it doesn't matter, but I'm writing it just so you see how the rule works, right? So this is all this right here is capital F of B from the fundamental theorem. All of this right here is capital F of A. You're subtracting B and A. Anyway, this is 0, so we'll just work with this part. So you got 16 times 2 cubed is going to be what?
8.
Real tough. I can divide one of those 2's out, so that would be 1, 2 plus 2 minus 0. All right, so where's this going to be? One
128.
over 3.
It's 42.666.
40 what?
It's 42 is 666 in decimal. Yeah.
Let me check. You sure about that?
No, it's
no.
28.67
28, right?
actually.
Okay. Anyway, any questions on the procedure?
No, but before I forget, can I talk to you after class?
Sure.
Thanks.
28.66. Okay.
Did you already ask him that, Felipe? Or was that Roberto?
The what?
Someone earlier asked to talk to Jack after class.
I don't know.
No. Not me.
Okay. Let's do some that have square roots. So if you have an integral with, let's say, 2 times the cube root of x dx. You have to change this into a power first to apply the power rule. And the 2 can always be pulled out if you want to. I just tend to ignore it until after the integration happens. Whatever you want to do. So I can change this into a power because cube root means 1/3 power, right?
Mhm.
So now integrate it, and you'll get 2 times x to the 1/3 plus 1 over 1/3 plus 1. And since I don't have bounds, I have to put the c. So my result will be 2 times x to the 1/3 plus 1, was that 4/3? So that'll be 2 divided by 4/3, that'll be 6/4. Any questions from any of the steps? So the integral's making sense.
Yes, sir.
Okay. Let's do one that's a little harder, and we'll put bounds on it. To evaluate the definite interval, actually, it's a different one. Integrate from 1 to 4. Of u minus 7 over square root u. du. All right, so you have to separate this and change it to a power. So let's do the separation first. Well, no, let's change the power first. So this is u to the 1/2, right? So separate it. So you have u over u to the 1/2 minus 7 over u to the 1/2. Okay, so we should know how to divide these, right? That'll be u to the 1 minus 1/2 minus 7, and I can bring this to the top using my exponent rules. So it's negative 1/2 du.
Is that u to the power of 1 minus 1/2?
Yeah, so this is the 1. So you're dividing these two out. So you're going to do 1 minus 1/2, right?
Got it.
So the result will be u to the 1/2 minus 7u to the negative 1/2 du. So at this point, do the integration. It's so then all these steps before, we're just setting up the problem, right? So now they're straight up power rules. So this will be u to the 1/2 plus 1 over 1/2 plus 1 minus 7 u to the negative 1/2 plus 1 over negative 1/2 plus 1 from 1 to 4. So the result will be 1/2 plus 1 is 3/2, right? Negative 1/2 plus 1 is 1/2. So when they're fraction, it's a little uglier. But it's the same thing, right?
We could still get the answer from this point though, right? Without simplifying or,
Yeah, I think so. You mean like plug in the numbers and then divide, or what do you mean?
just not simplifying it and then just, yeah, plug in the numbers now.
You could. But I would rather plug in something nicer into the calculator because this looks gross. So that would just give us 2/3, so it's not a big deal. Right? 7 divided by 1/2, that's the same as 7 times 2, so that's 14 u to the 1/2 from 1 to 4. Okay. So then the integration is done. Antiderivative is right here. So just plug in the numbers and we're done. Okay, so I'm gonna plug in 4 into both, minus plug in 1 into both, and that's it. Looks like it's gonna be maybe negative. But anyway, any question about the algebra on the way there? All this crap up here. All this is algebra.
To be honest with you, Jack, it's hard to tell the difference between algebra and calculus at this point. I'll just call it working the problem.
Well, as soon as I do the integral, that's calculus right there. This from here to here is calculus. But all this is just preparation.
Yeah.
I still, like I said, I can't tell the difference between what is algebra and what is calculus. It's all math. So that's about all I call it at this point. I haven't not yet had the time to be able to properly categorize it, I guess.
It's all good, man.
I do understand it, but I just can't tell you what the difference is.
As long as you can solve it, it's all good. Okay. So you guys okay with so far on this problem? All right,
Yep.
plug in the
Yep.
numbers and see what we get. Is there a question?
Nope.
Is this what it was? 2/3 u to 3/2 minus 14 u to the half
Yes.
from 1 to 4.
1 to
Yes.
4.
Right, 1 to 4.
All right, so plug in the, it's always the top first. So 2/3 of 4 to the 3/2 minus 14 times 4 to the 1/2 minus, gotta put parentheses here to be safe, because you're subtracting everything from the result when you plug in 1. So this entire thing is subtracted. So 2/3 times 1 to the 3/2 minus 14 times 1 to the 1/2.
So when we're using the fundamental theorem of calculus, like when we're bounded like this, it's actually giving us the area under that graph, right? Between the
Yes, you're in the area underneath the graph. If the area comes out negative, it's because it was in a negative region, because negative area doesn't make sense. So let's keep that in mind. Okay, so the 4 to the 3/2 is going to be what? 8.
8.
2/3 times 8. That would be minus 14 times 2, right? Minus 2/3 plus 14. Okay. Got 8 of them minus 1 of them. That's 7 of them. Right. Negative 28 plus 14 is negative 14. Okay, so that's 14/3 minus 14. So that's negative 28/3. Is that what you guys got?
I'm just writing.
And if you show me this step here, you can plug in the calculator at that point if you want to. I just want to see that you understand where the numbers go, right? After that, you can just plug them in to your machine.
At the third line from the end, is that a 7 inside parentheses?
Yeah.
It's because I have you split on my screen and your screen is smaller, so that's why I'm having a hard time. I don't have my second monitor today.
Oh, I see. Let me see if I can. That's too.
I'm in a similar boat. I'm on a totally different. I'm in a totally different setup. I'm not in my usual
yeah.
room. I had to put in some new chips in my computer and haven't had a chance to rehook everything back up.
That better?
Yes.
Yes. focus. Maybe you want to focus a little more. The zoom is fine, but the focus just a
Let
tad.
me try it.
Right. Yeah, right there. It's perfect. Thanks. So, is your class full for the fall? I remember there was 8 spots, and now I haven't looked at, but I already registered.
For Cal 2,
For Cal 2.
I think, I have no idea. I need to check.
Yeah, I'm registered in that class as well.
Yeah, it's gonna be face to face, no? 8 to 10, I believe. Yeah.
Mhm.
That's if the class makes a certain number, I believe. I
I'm
I'm
finally,
pretty sure they're
fin-
gonna keep it going.
it's so I finally got the proper answer. It's the classes that make a certain number will will be allowed on face to face, while other classes will not.
Let me see here. Looks like my Cal 2 has 5 people.
Yeah, it was 8 people last week.
Yeah, me too. I guess
Your
this.
pilot, yeah.
Yeah,
Well,
I see Tyler's in there. Felipe, you say registry? Yes. Yeah.
Yes, sir.
Is that for the summer or next fall?
Fall.
That's for the fall.
Fall.
There's 3
Oh,
spots.
okay.
But yeah, it will be in person though.
Yeah, these fall semester I have 3 classes, and I think I'm gonna be super tight. It's gonna be physics, Cal 2, and engineering graphics.
Oh, nice. I was doing the graphics, but there was a miscommunication. They changed the schedule.
Really? So what is it? What are they gonna see in graphics? CAD, AutoCAD?
Yeah, just AutoCAD the whole time.
Oh, all right.
Let me know if you need help. If you want a tutor, man. I asked Jack. I made teacher's assistant after doing the class once.
All right, man. Right on. I'll hit you up.
Yeah, I'm in it right now with Mr. Gonzalez. It's pretty chill. It's a lot of drawing. Not a
Yeah.
fan of the book though. The new book,
The new one or the older one?
the new one, like some of the answers are kind of contradictory to like what you read inside the text. Like they'll say one thing in one part and say something completely different in the other part, and in the wording it comes out different. That's why I was asking if we could look at the answers to the end of the chapter summaries, but I know they're like the test questions. So
Yeah,
You have the textbook, like the actual textbook, or it's virtual ebook?
they should send you the book. Well,
I'm not good at reading on the computer. It's kind of hard for me.
me either. I always try to get the books. That's why I was trying so hard to get the book for this class instead of trying to.
yeah,
Like I still have my AutoCAD 2016 book.
for graphics, they buy you the book and give it to you.
If anybody has the book, the actual textbook, I can buy it from them.
No, I'm
I
not
think
giving up that
I
book.
have the book, but I don't know. It was like the last, because just barely this last semester they updated to the new version, but supposedly it's the same as the old version. So I think I have the old version, but you could keep it. Like
All right.
I'm done with that class.
Right.
I'm
Just,
never gonna
just
get
try
rid of
to
that
find
book.
out if it's the
It's-
book. Like if you could use the old one, you're so much welcome to like take it. Like I don't need it.
All right, maybe we can,
Well, as far as I can tell, the difference is formatting.
maybe we
Right.
can change numbers on mine so I can see.
Yeah, of course.
Thank you.
I wouldn't be surprised if the end of the chapter, like the chapter questions are like from the old book and they just copy paste it and then change the material. That's how I feel sometimes when I'm doing the end of
Yeah.
chapter reviews.
I didn't see any difference personally.
I remember when I took the class, I actually managed to piss the teacher off. Pardon my language. it was funny. I walk in day one and I have 3 weeks of homework completed, and then some, because I went ahead and in the book and did a section of did a full like 2 chapters worth of drawings. That the book listed was homework, and printed a few of them out. And I basically just had to hit print, use the classroom printer, and I walked up and handed her here you go. And the look on her face, she's like, what? And I showed her the files of all these AutoCAD drawings I did, and she was like, she's kind of her jaw just hit the ground. And why are you that far ahead? You learned how to do all that already? Yes. I started fooling with it. I've had the software for a while. Not my first CAD. So she was
No
like,
wonder
I was
Mr. Gonzalez
experienced.
has all homeworks locked.
For which one?
Well, I mean, don't you have to finish one homework in order to go to the next one?
Yeah.
No,
No.
It's,
because we have
it's-
students like Tyler right there.
Yeah, no, I don't think so.
Right, guys. Let's get back to work. Getting late.
I did this before Jack came in, though. This is
Yeah,
before
right,
Jack
keep
was
going, keep
engineering.
going. Let's get going.
Sorry, man.
It's good.
I tell that story every chance I get because that's the teacher that framed me for assault.
Yeah, I remember, man. She's something else, but let's get back to it.
Let's
So
do next, DX.
we're gonna do some trig functions. So you have to have these memorized or have a list to be able to go backwards, right? So before we start, what is the derivative of sine?
Minus
Cosine.
Cosine, right? So the integral of cosine would be
Sine.
doing that derivative, right? Now, what's the antiderivative of sine?
negative something.
It has to be negative cosine. Because the derivative of cosine is negative sine, so I need another negative to make it positive. That makes sense? So this derivative would get me a sine. So these you kind of have to remember or have the list. So have the list of all the derivatives. That way you can just look backwards because that's what you're doing. You're undoing the derivative. So integral of secant squared would be what?
Tangent x.
Yeah, exactly right. 10x plus c. But since these are all indefinite, I have to add my c. Wait, does that make sense? Or no?
Yes, sir.
All right, so that's pretty much it for 5.4. You guys have any questions on like the fundamental theorem? Do you see how it works? How we're doing the b minus the a? Do you see how we're just doing power rule over and over again, right? In the beginning here. This guy. This is what we're using the entire time.
Yeah. That's what I was okay.
All right.
Much easy.
Any question on 5.4? All right. You guys have any homework questions? And you guys said you had a few.
5.1, number 4.
5.1.
Oh, what do you know? I have that one too. Bingo.
Number 4?
Mm-hmm.
Yes, sir.
Okay.
Oh wait, not that one. Not 4. I have 1 and 2. I somehow got wrong.
This guy, right?
Yes.
Oh, wait, what's that?
So what they did first was apply the 5 to the 3. So 3 to the 5th is 243. So they pull that out. X to the 5th, they move that to the top, which becomes a -5. So once they have it up top, you do the power rule. So let's do it on paper. You can see what I'm talking about. It's not too bad. It's basically what we've been doing. Just the way they set up the question, I think, is a little weird. Let's see here. So it's the integral of 7 over 3x to the 5th dx. So the first step is apply that 5 on each part. So that'll be 243 x to the 5th. After that, you pull out that number, 7 over 243. See what I mean? Then you pull this up to the top. So that becomes x to the -5 dx. So at that point, you just do the power rule, right?
How did you get that -5 power to the -5?
But the algebra rule, it says 1 over x to the n is equal to x to the -n. So you can change it anytime you want. If it's on the bottom, you can bring it to the top, but it has to be negative.
Got it. Yeah.
If it's already on the top, I can force it to the bottom and make it negative. So if it crosses the line, you change the sign. That's it.
Got it. Got it.
So at this point, you do the power rule for antiderivatives. And you get to here. So this, we're pretty much done now, but we got to multiply those numbers. I think it's going to be 972. So we get 7 over 972 x to the 4th. I bring the x back down to make it positive. And this whole thing will be negative because -4. So -4 times 243 is 972. 7's up top. This makes it negative. So let's go back to the question. So they applied the 5, right, on this guy and that guy, but they skipped the 7 and they went ahead and brought it up to the top. You see that?
Yeah.
Then they did the power, so they got -4 divided by -4. That's what we did. So they skipped a couple of steps there too. Then they multiply that out, and they got this number.
I see. And let's not forget the C.
So I added double the steps so you can see what's happening. But
Yeah.
again, you see what happened or what's going on?
Yeah. I see it now. Thank you.
Why the 7 is negative over there?
So you can put that minus anywhere you want, in front, on top, on the bottom. Same thing. We just know that the entire term is negative. All right, so I can leave it up top. I can leave it in the front. Right. Or I could put it on the bottom. Technically, these are all correct.
Okay.
But usually we leave it in the front. It's a little far, but in the books usually just put like right there, meaning it's
Mhm.
entire thing is negative. But if you want to, put it on the top or the bottom.
Okay.
Any other question on this problem?
Oh, thank you.
All right. Any other questions on 2 or 5.1?
Be honest, problem number 1.
Number 1.
Uh-huh. I don't know. I honestly just don't quite fully.
So you remember the dy dx means derivative, right?
Mm-hmm.
So if
And I
it
found
wants
the
to be-
derivative of it, but I think I did, but I don't, and I entered it, but I don't know what I did wrong.
So this is the derivative, right?
Mm-hmm.
So they're asking you to find the general solution, meaning they want to find y. So y would be equal to the integral of dy dx. In other words, integrate this function with respect to dx. That's what y is going to be. So that integral
Okay.
is going to be 3x to the 2/7 plus 1 over 2/7 plus 1 plus your c. So that will be 3x 2/7 plus 1. That's 9/7, right?
I think so.
Okay. Divide that out. We should get 7/3 x to the 9/7 plus c. So this right here is y. So y is equal to this.
Okay. So just add. So if I do this, so I solved for the y. I managed that far, but it still gets me wrong. So I have 9x to the 4/5. I solved for y, got 9x to the 9/5 power, and entered that. It gave me wrong, and then I used the plus c, like you just said. 'Cause that was a different problem, and it's still wrong. So
Yeah, you just gotta make sure you follow the steps, right? You gotta add the 1 and divide by the result, and then do your algebra, and just make sure that it's has a c. So you're only gonna type in this piece.
mm-hmm. Yeah, that's where I'm running into issues, because I can't seem to even find. I added the plus c, but I can't even seem to find the proper derivative at this rate.
You have to find the antiderivative using the power rule. That's what we used.
Oh, we're doing. Oh wait, this is antiderivative.
Yeah, this.
Okay, that explains what I'm doing. I'm looking for the actual derivative.
'Cause
Doink.
you're given the derivative. This is derivative right there, right?
Yep.
What this means, and they want to know what y is. So do the antiderivative.
Okay. What? So not 9x to the 4/5 would be the antiderivative. Okay, y over x plus not or minus 9x to the 4/5. I disregarded that when I was working on that because I misunderstood the problem. Minus. And let's see.
All right. You have any other questions on 5.1?
No, sir.
Any questions on 5.2?
Yeah, I have a few. I think. Let me pull that up. So I did this with a skimming of the video. I didn't have time for the full watch, unfortunately. Oops, that's back to 5.1. Need 5.2.
I know we're about to run out of
Summation formula.
I know we're about to run out of time, but next class, can you help me with the problem on 4.6? It's literally the last question out of all my homework.
4.6, you said?
Yeah, I've tried entering in the answer every possible way, and it won't take it. But it wants to know the relative max and min, and like I found it, it just won't. It won't take it. So maybe I don't understand why I'm getting the wrong answer. But
Okay, I'll call this whatever. I'm like you guys. I am tired. Sorry for taking up
I
time.
know the class is
That's
over
fine.
right now.
I'll wait. Do you want to do your question, Tyler, and then I can do his, or are you cool? Or?
Nah, I'll probably just try and rewatch the video and ask again on Wednesday.
Okay. What was your question? Is it, Trevor? Is that where you?
Yeah. My question is 4.6, number 6.
All right, let me find it. 4.6, number 6. Alrighty.
I'm trying to actually find it now in my notebook.
What was your function?
So my function was it was x cubed over x squared minus 25.
X cubed. Let me write that over again. Say it again.
X cubed over x squared minus 25, or x minus 5, x plus 5.
Like this. Okay. Gotcha. And you couldn't find the relative max or min?
Yeah, that was the only thing. Like I have the derivative, and then I set the numerator denominator equal to 0. Obviously, denominator doesn't count because those are the asymptotes, I believe. And yeah, they are, because -5 and 5 wouldn't be included in the domain.
Let's see here. Okay.
Hope you forgive me. I gotta clock out early. I gotta be up at real early in the morning. I got a job.
All right. See you, man.
See ya.
Give me one sec.
Yeah, no worries. It's the last, like I said, it's the last problem that I have, like, out of all the homework.
$5.196. Okay. So all you need is the relative max and minimum, you said? This
Yes, sir.
should be this here. You see it? Is this what you got?
Yeah. So my thing is, I don't know why it would be. I mean, I get why it would be that. 15 to the square root of 3 over 2. Yeah, I mean, I got the x values, but when I plugged them in, I mean, I just plugged it into a calculator, so I wasn't getting, the 15 to the square root of 3. So I guess that's my issue.
Yeah, they want exact answers. So you have to plug this weirdo number as a cube.
Yeah, exactly.
So, I mean, you'd have to do it by hand, or use a.
Yeah, for sure.
Yeah. You could use.
The only reason I didn't even do that is because every other problem, it just took the calculator answers. So yeah, that would be the issue for sure.
Yeah, that's fine. I mean, no worries. I mean, you're not gonna have anything that ugly, I don't think. I don't think you did.
Yeah, because I was just being lazy about it. I should have just wrote it out in hand. That was actually the only thing I didn't try.
That's
All right, thanks.
Yeah. I guess we're about out of time. So I guess next time, let me think. Today's Monday, so on Wednesday, I guess we can review and answer more questions. Go from there. And
So
I'll push-
I'm sorry.
I'm gonna push the test till probably by Sunday. I mean, I hope you do it sooner, but I'll do it till Sunday.
Sunday the 8th, the 9th.
Yeah,
Okay.
Oh, wow.
but if you wait till the 9th, remember that means you have less time to study for the final. So use your time wisely.
Hold on. The final test is, we can take it up to the